Perfect. Hi everybody, my name is Ian Lees. I'm the head of R&D here at Quantexa. So I'm going to give you a quick overview of what we do at Quantexa, and then I'm going to go into a quick talk about event sourcing and how we use it here at Quantexa. So starting off with who are we? So Quantexa started about 4 years ago. We've grown to about 250 people in that time all over the world. We basically work in the world of fraud and financial crime, so our clients are big banks like HSBC, governments, insurance companies, and we basically help them with fraud and financial crime problems, so be that money laundering, people trafficking, fraud. Fraud is a real sort of big data problem, and our software basically ingests huge volumes of data and looks for anomalies and hidden links within that data. As far as stat goes, it's all Scala, pretty much. The core platform is all written in Scala, and a lot of our data engineering and data science is also using Spark and technology like that, so there's a lot of Scala going on. Obligatory, we're hiring. Scala engineers, data scientists. Cool. On to my talk then. My talk is going to be a sort of a lessons learned in event sourcing and CQRS. So I'm going to cover a very quick introduction of what it is, how we actually use it here at Quantexa, and then on to some lessons learned. So very quick show of hands. Who here has heard of event sourcing before? And keep your hand up if you've used it in production. Cool. So hopefully quite a few people have heard of it. I'm going to do a very quick introduction. There's definitely much better versions of introductions and stuff online and videos, etc. But I'll do a quick one just to sort of set the scene for anyone who doesn't know what it is. So, event sourcing is a technique when it comes to persistence. So the idea is that rather than a traditional database schema or something like that, we store our data as a log or journal of events. So every time a new event sort of enters the system, what we do is we append that to this immutable log, and that's basically it really. All of the state is kind of kept in memory. So quick example, just to sort of bring this to life a bit. So classic shopping cart example here. I've been doing some shopping for the R&D bookshelf, so I bought myself 2 copies of programming in Scala and a copy of the Red Book. So how would we represent this in a traditional database? So we probably have some sort of table, we've had an ID for the cart with a couple of columns, and we've put a couple of rows in that represents the number of items in the shopping cart. How would we do that in an event source system? So it'd look a bit more like this. So here I've got 3 events that I've appended. They're basically the same data under the hood. It's this add item event, and there's 3 of them. So why do we do this? It's a bit more complicated, a bit strange. So the idea is really to separate the write representation from the model that's in memory. So this is loose coupling, so it's a good thing. One of the nice things that it does is it doesn't throw away any information. You probably saw in my event log previously that I had 3 events because I added 1 book, then another, and then I went back and added another book, whereas the database version didn't have that. So we've actually thrown away some information here. So by persisting the raw events, we keep that, we don't throw anything away basically. Finally, rebuilding the state is simply replaying or folding, because this is a Scala even, along the log to add all those events and build up the state. It's kind of as simple as that really. So what is CQRS? So it stands for Command Query Responsibility Segregation, and the idea really here is we are separating our reads from our writes and all of their different concerns. So we can have a different model. Obviously, when we replay events in memory, it's ON with however many events we have, but obviously our users expect snappy, responsive websites or things like that, so we need to be making sure that we're optimizing our reads for the end user's use case. So, maybe we'll stream some events into Postgres just to have a table that we can look at. Maybe we'll build a search index in Elastic, or send it off to Kafka to send it to all different parts of the organization. So that's nice. It means we get really efficient reads, because we've got this read-only representation that we can use, and we've got efficient writes because it's just an append-only log on the back end. Cool, so that's everything I have for an overview. Like I said, there's definitely some really good ones online that will go into sort of pros, cons, and all that sort of stuff. So what do we have when it comes to event sourcing in Scala? So probably two big sort of frameworks here. So ACA persistence is probably the most popular one or most well known. So here we basically have the idea of a stateful actor that stores events in a journal. Each actor represents a persistent entity and gives you the ability to persist state, replay the state, etc. This is classic persistence here, so there's probably, there's also the new typed persistence, which you're going to hear about a little bit later, I think. At Quantexa, we use classic ACA persistence. Another really interesting framework is called ACOR. So the tagline on GitHub is a pure functional library for defining and running event-sourced behaviors. So it's definitely a very principled, very functional approach to event sourcing. It's really interesting. Under the hood, it has a runtime for ACA persistence as well. And there's a really great blog series. There's a link there. It's like 5 blogs about event sourcing, CQRS, and sort of motivating it all using ACOR. So yeah, I definitely recommend that. They're really good. Okay, so how do we use event sourcing at Quantexa? So we use event sourcing in multiple services across the platform. Probably the most interesting, the most complex is the thing that stores the investigation. So we work with fraud investigations, and we build these complex-looking graphs of nodes and links and stuff. Basically, everything you see on that screen pretty much is event sourced. So we're storing events for additions, removals, the data being updated in the back end, that sort of stuff. So yeah, it's quite interesting. It's quite a complex and rich data model, and we use event sourcing behind that. We also use it for things like access control log, that sort of thing. Cool, on to the lessons. So I'm going to start with event sourcing lessons. My first lesson isn't really a lesson, it's more just that event sourcing is really good. So when we first started Quantexa, one of those key things when you're starting a company and going to market is being able to deliver at speed, get your proposition to the market. And I really believe that event sourcing enabled us to do that. So because we have a very rich data model, when we wanted to add new features and functionality, all we had to do was add a new event, add some new data to that event, and that was pretty easy. And it's nice, it aligns well with Agile, which probably most people in the room kind of know about. And yeah, so we have a very complex data model, as I said, and it's really nice that at any point when we add a new feature, we can just refactor that in-memory representation without even having to consider the events that are stored in disk, because we've separated that. So that's a big plus. Also, migration. So anyone who's put a large database or something into production has probably considered having to do a database migration at some point. They're kind of scary and a bit nail-biting. You need to make sure that they work, and all that sort of thing. One of the nice things about event sourcing is there's an asterisk there, we don't really have to think about migrations quite as much. We just add new events, and we can kind of don't have to worry. In Quantexa's case, if we had put our rich data model into a database table, probably 20 odd tables with relationships and stuff all over the place, and we'd probably have spent as long thinking about migrations as we would have for thinking about adding the new features. So I think that's a big plus. Also, as a bonus, you get when you add new functionality that uses data from old events, it just magically works. So the classic example here is like an audit log, and you add that piece of functionality and you can show that to users, and it's something that really impresses users, because traditional systems don't really have that ability. So they get a new feature and it works with all of their old data, which really impresses people. Cool. So another lesson or thing to consider, backwards compatibility. So while we don't have to consider migrations in the same way, we do need to consider legacy events and backwards compatibility. So as we add features and new events over time, we'll need to make sure that we can read old events in and are ready for when we add fields and remove fields, that sort of thing. So, you know, the sort of best, I guess the standard for this is using something like protocol buffers from Google. This is used in Akka under the hood. And yeah, it's basically, we can define these message schemas over the back, and then it basically compiles code for us, which we can then run. And yeah, it handles all the things like fields not being there or fields being added nice and gracefully. A tip here, I recommend that people should add like a creation version number to their top level events. We have, if you look through our message files, you occasionally see, you know, comments above new fields like added in version 1, added this in version 2, version 3. And then we sometimes get strange bits of code like, if this option is none, and this is 0, and this string is empty, it must be version 4 or whatever. So yeah, do yourself a favour and stick a quick integer in there or something just to mark up the number. It'd be a lot easier and less error prone. Next one. So consider building some tooling. So, you know, obviously one of the things with event sourcing is we've got a very different representation of data now in the actual data store. With a SQL database, you know, just log in, select star from table, and that's how the table's behaving. You know, that's how the database is and what the state of the system is. With event sourcing, obviously, we deconstructed that all. Our events, especially if they're in binary, kind of hard to read and look at. And also, it doesn't represent that sort of end state of the system that the users are looking at. So, I recommend building some tooling. It's useful for developers, operations people, support teams for debugging and that sort of thing. You know, it can be sort of quick, hacky scripts or a robust tool. But yeah, it's definitely very useful. Consider compressing your events in the log, especially if the events get quite big. Like ours are these rich fraud investigation events. They actually compress really well. You know, this means it keeps the log small, it's easier to work with, things like backups are smaller, take up less space, testing, you don't have to carry as much data around, things like replication and network bandwidth, all of these are cheaper, just generally easier because it's all smaller. It does add a small overhead to reads and stuff, but once the state's in memory, that cost is all paid, so that's kind of not too much of a problem. We haven't seen too much an overhead with that. And yeah, if you do this, tooling's even more important. You know, while you might be able to open a binary event in a text editor and make out a bit of it, once you've compressed it, it's definitely all better off now. Snapshotting, so consider snapshotting. Snapshotting is useful. It's this technique in event sourcing. When an entity gets a really long log of events, obviously replaying is ON for the size of events, and yeah, for a very popular entity or an entity with lots of events, it will take a long time. So what a snapshot is basically this idea of taking a snapshot at some point in time to cap the size of n. So it makes replays sort of shorter. This is good, but you're now persisting a memento of some sort of internal state. So obviously we've stayed away from having our in-memory state persisted anywhere, but this kind of introduces that back. So at some point we now have to think about migrations or backwards compatibility. It's kind of nice, you can just throw them away, any old ones that don't really fit, but yeah, it's still something to consider. We actually haven't needed it yet, and I kind of feel we should hold off until we do. Okay. Event and state design. So I guess the lesson here is think hard about this. So, you know, we all know that we'll never get designs and data models right the first time, but it's definitely worth sort of sitting down and having a bit of a think. We've got a case in a lesson learned in our code base of once upon a time we decided to store a reference of something as a name, and then at a later date we decided an ID was much better. So any of our sort of legacy installs have a mapping file from the names to the IDs to repair that. So, you know, and that's sort of in there for a while now in those older installs. Also, yeah, state machines, types are great things. You should definitely use those to the fullest. You know, ADTs and things like property-based testing, all that sort of thing, to make sure that you really understand your domain. You want to avoid designs that can get into illegal states. You know, the system actually has to protect itself from persisting a bad event into the log. once a bad event does get into the log, it can be a bit of a pain to remove. You have to go into the database and delete rows, that sort of stuff, which can be a bit of a pain to sort out. Finally, separation of concerns is a good thing. I guess I felt like I said that quite a lot in this talk. But yeah, keep your persistent entity as simple as possible. And so we use Akka persistence, and it's just an actor under the hood with additional things for doing persistence, etc. Don't be tempted to do things like executing service calls, adding business logic, faking transactions, that sort of thing in there. What you're doing is you're conflating lots of concerns all into one actor. It kind of makes it a bit harder to test, harder to work with, and harder to reason about. So try and avoid this, be disciplined. There's actually a pattern called the process manager pattern, and it's just this idea of orchestrating logic and orchestrating different events for more complex sort of chains of actions. So yeah, definitely recommend using that. So just last few lessons now in CQRS. So the first one again is CQRS is really good. It's really good decoupling, separation of concerns. This different read representation is really useful. Yeah, the system does become more complex. You've got a lot more moving parts. You're embracing eventual consistency, but it's definitely worth it. So examples of this are lists of entities in the system. We actually have an access control list as well. We do quite a thing that I've always been pretty proud of, where we the list of all of the different fraud investigations that an investigator can see. We're streaming the access control list and the list of investigations to a data store, and then joining on that so that each user gets their own view of the investigations that they can see, which I think is quite cool. Migrations. CQRS kind of brings back migrations because now we've got this read-only view in a data store somewhere. So if we do decide to change that, add some new functionality, we might have to migrate. The good news is we can just throw them away. So we've got all the states in our journal, and all we have to do is replay all of those states through the view materializer, and there we go, there's the new version. As this has to go through, it can take some time to do this, as all the events in the system. So you might want to consider doing something like a blue-green deployment to minimize downtime. So rather than having all your users having to wait while the log replays and populates everything in the background. Cool, last one. So handling a failure. So the view materializers, or whatever we call them, they're a critical part of the system. We need to monitor it, make sure it's up, make it highly available. If these things go down, users will notice. They'll sort of see that they clicked here and maybe added a new thing to the data store at some other point, and then they'll go to the list and they'll be like, my item isn't here. Now, users don't know that we've got this really cool, eventually consistent event source CQRS architecture that they should be really impressed by. What they see is that the system is inconsistent and that it's not quite working. And this sort of means they might not trust the system and how it's working. So yeah, they will notice. So yeah, we need to make sure these things are handled correctly. We need to handle errors correctly. We can't just drop errors or ignore things. So yeah, make sure you're sort of looking after these things so that your system, while it is eventually consistent, gets to consistency as quick as possible. And that's it. So thank you very much for listening. Like I said, I think we're big fans of event sourcing, CQRS here at Quantexa. I definitely think it's more complicated. We've embraced that complexity and it's definitely paid off. Thank you very much.